Okay. Let's talk about Virtual Volumetric Efficiency Assistant tool that I wrote. It's coming along pretty nicely. There's a lot of new features and enhancements to discuss with this, and I want to get you guys kind of clued in now. And then as future updates come out, it should all be following the same workflows and same ideas. So you may see new things pop in there, but once you know the basics, you'll be good to go. Now, the first time you open this tool, you notice it's saying warning zone definitions are not found. So we need to give the tool a concept of where your zones are and how they're broken up. So for that, we just go to View, Define Zones. And then we're going to hop over to our editor and we're going to go to Virtual Volumetric Efficiency. Click the option to show zone numbers, highlight the entire thing, copy with axis. Always copy with axis. If you don't, you're going to jack it up. And so now we'll just hit paste from clipboard. We're going to let this thing rock and just hit save. That is it. Pretty simple. Now we have a few other tabs that we need to fill out. So we have the histogram and it says input. So what do you think we're going to do? Yep, let's input that histogram. So I'm going to go over here, copy with axis, always copy with axis. And it goes without saying, your column and row header definitions, they better be the same, otherwise you're not going to get good results. So I'm going to paste that in. And you'll notice the performance, I'm not too happy with the way it's importing. I recently added the ability to manage the decimal places, and that seems to have really jacked things up. So future enhancements or fix, maybe I should say, is to fix the performance, the slow performance. So that's coming, but it's still, pretty awesome as is. So now you can see we have our zones defined here, and now we need to put in our virtual volumetric efficiency. So back in the editor, we're going to uncheck show zone numbers, right click. Hey, if you guessed copy with axis, you get a quarter. Go over here, paste from clipboard, let that wait. And now after this comes in, then we're going to do the same thing to new. And the reason why is because we haven't changed anything yet. So the importance of this and what differentiates this tool from all other virtual volumetric efficiency utilities out there, and including what HP Tuners has available out of the box, is none of them account for the histogram. So you can go into this editor and you can raise and lower stuff willy-nilly, but you don't know if that's good or bad. And then as soon as you hit calculate coefficients, you're floating out in space in your own little world. You have no way to know that what's happening. So that's the importance of this histogram. It's marrying this data to this data, and as you go along, you're going to keep updating this new value, and then you're going to get feedback with this area right here. Now, this whole screen is kind of what these 4 tabs here is kind of what I loosely refer to as basic mode. And we're going to get to professional mode here in a second. But what this is used for is for your normal Gen 4 and Gen 5 stuff where you're not dealing with variable camshaft. So this is just straight up virtual volumetric efficiency. That's it, no cams. And this is super effective. So you can see we have some data in here. And I like to tackle things personally zone by zone. I don't like copying the whole thing, going back to your editor, doing this whole thing, and paste special. We can do that. It's not the end of the world. And so, but let's see, how well did that change? Well, first of all, before we do that, what you can do this zone by zone, right? And you can do stats, which I kind of like to do. So hey, not bad. We were plus and minus 4%. Our average is just barely rich, and our standard deviation isn't too bad at 1.7. If we look at the whole table, we can do the same thing, and overall we can see 2.5. All right, so that's our starting point. So we're going here, we're going to do copy with axis always. We can go here to the new tab, and I can do paste, but I'm lazy. So I added the same link up here. So if I click this, it's also going to update this tab here. And now we can see how we did. And this is kind of where the whole iteration starts coming into play. You're going to keep going. So let's look at this one. Stats for highlighted area. 2.2 could be better. So I could copy this, and we're at 46 and 1000. So I'm going to go 46 and 1000. So right here, paste special, multiply by percent, calculate coefficients, whole table, copy with axis, come back in here, paste from clipboard, and guess what? When this comes back, again, the slowness is terrible. It used to be instant, but it's killing me. So it will get fixed. So now it can do the whole thing right over. And, also I like to save this and then come back in and then start with a little fresh because I like to see the colors. So now I can do paste special, multiply by percent. If I wanted to interpolate here and there, I can do that. You don't have to, but you can. Hit calculate, copy with axis, go back in here. And basically you're going to keep iterating and getting this to a point where you really like it. Um, and then there's a few other options, and you can dig around in here, by the way. Colors. I like the heat map, but if you prefer this look, I don't know why, but it's in there. You can turn these red bars on and off. Histogram output. So right now it's set to percent, but if I change it to literal, this isn't going to give me a percent, but instead it's going to give me the actual values to copy. So I could do copy, and then when I come in here, I would just have to do a regular paste. I don't do a paste special because we're not dealing with percent. So then I paste it, calculate coefficients, and I'm not suggesting you do this. It's just an option. I like working with the percents myself. Paste it back in. But I just kind of want to demo some of the functionality. And this is something, if you wanted to save it off to an Excel spreadsheet and crunch your own numbers or do whatever, certainly could. Let me set this back to percent. And you also have the squelch filter up there. So if we look around, it's kind of busy. Now this isn't a big histogram, but you may have histograms with a bunch of cells in here, and you probably don't want to be bothered by something that is 0.03% or 0.1%. That's pretty small. So we can get rid of the outliers, the big numbers, but also the little numbers. Or when I say little, I mean the ones hovering right at 0. So, and we can change these. Like, if I'm not too selective, I can change this to plus and minus 1%. And I don't think we have anything above and below the 20 threshold, but we could certainly change those if we wanted to as well. Not a big deal. But just giving you the option to kind of like allow you to focus in on the things that you want to focus in. So the whole point is you're going to keep doing this. Whether you go zone by zone or you do the entire thing, you're going to keep going back to HP tuners and hitting this calculate coefficients button. Now, heads up, I am going to be working on my own ability to calculate the coefficients. That is a difficult process. And then, guess what? If I can calculate my own coefficients, then this tool is going to calculate coefficients, paste the results back into itself, and keep calculating the coefficients until it comes up with some numbers that basically put it in, in a range that you want, whether that's plus or minus 5% or plus or minus 1%. It's going to keep going and going and going until it gets you to where you want it to be. And then your fueling should be pretty much spot on. Now, you'll probably still need to go in and check out the overall shape and make sure you don't have any rough transitions and all that kind of jazz, but still, even better, auto tuning. Sweet. All right, so this is the basic module, right? And this is, like I said, no cams. But what do you do if you have cams? So for that, you can go into View and you go into Professional Mode. And by the way, this program is made to work on 1280 by 768 resolution. So if you have an older laptop, this should be good. If for some reason it's cut off, like if you have, God forbid, an 800 by 600 screen or something like that, you may not be able to see all of this. Um, so if that's the case, like if you're over here, right, and you're like, oh, I can't see over here, you would just need to drag this off screen, basically, or maybe this would be, if you can't see it, you're going to drag it over here so it's off screen so you have room to drag this back out. And then, you can drag it over here to look at it. Just giving you some options if you do have an antique that you're working on. All right, so in professional mode, you have 3 tabs. So we still have the same histogram, and this histogram is harvested from over here. Well, not this pay special, but this one here. So if we do professional mode, you'll see these numbers now match up. And so anytime you change this histogram over here and launch professional mode, this will get pulled in and vice versa. So if somehow this is changed, when you exit out, it will come over here and refresh. But you really shouldn't be editing the histogram anyway. But so we have this, we still have the same ability to merge and the same options for merging. Now, raw coefficients. There are a bunch of these guys in here. And so we can see we have these here. So this is the pain in the butt part, and this is something that, yes, I'm going to be working on. And so you're going to see me kind of move as fast as I can and struggle through this. And so you can see they're clearly labeled which table they're coming from. So we're just going to copy these over. I thought I had all of these defined beforehand, but I guess not. But you can see, you can still work through them pretty quickly. It's not the end of the world. Just takes a little bit of time here. Right. So these 6 right here define the normal volumetric efficiency curve. Essentially, that is basic mode without cams. As soon as you want to edit the cams, which really the only reason you should come into professional mode, in my opinion, would be to deal with the cams. So to get that, we have the same kind of situation here. And so I will just copy all of these guys over. Nope, not the exhaust. Let's see, RPM intake. And we got the other 2 left. Oops, not that one. Okay, we're almost at the finish line. Oops, be with axis. Here we go. Okay, now we're ready for the magic show. Now that we have that, this is essentially kind of the same situation where we have the histogram, but instead of copying and pasting like the normal volumetric efficiency table, we've now added the coefficients to allow the program to calculate that 3D shape. And so when you go to interactive mode, we now have our virtual volumetric efficiency. Um, Now, this graph right here, um, if you have to right click it and you can drag it to go left and right. To go up and down, you have to left click. I like the HP Tuner style where you just right click and you can move it any direction. However, check this out. You can zoom into this one. So if you really want to get up in one particular zone and see what's going on, you can totally do that. Okay, so now we have these coefficients over here on the left. These are pulled from the combination here of what style that you want to do as far as your operating mode. Okay, and so we're saying, hey, we're at zone 0 and cam angle 0. So in this case, it's looking here. If we go manifold switch open in zone 0, so manifold switch open, zone 0. And so all of these guys essentially are going to be pulling from here. Now the cam angle doesn't actually come into play yet because the cam angle is zeroed out right here. So at this point, I could edit these values, but nothing would happen because this is preventing anything from changing. So if I want to switch zones though, and I move over, you can see it's pulling in the histogram data down here, and now it's also bumped all of these guys up to zone 1. And so it's recalculating this entire curve. So here we go. We have a lean spot. We're in zone 2. By the way, where the heck is zone 2? Well, there it is right there. So if you start getting into the weeds, like, you're at like zone 19 or some oddball like that, where is zone 19 on here? I don't know. But you can now look here. It shows you the general zip code of where you're dealing with. Okay, so where were we? Was it zone 2? Okay, so we have some lean issues that we need to deal with. Now, presumably, before you've even gotten to this part with professional mode, you've used basic mode and you've hashed out your virtual volumetric efficiency and your fuel trims are pretty good, right? So we'll just assume at this point, this log has been collected with a cam angle of 10 degrees. And you notice as I change the degrees here, the volumetric efficiency, this curve, is changing along with it. And it's now starting to apply these coefficients with this particular angle, which maxes out at 20, and the zone maxes out at 29. There's 30 zones, 0 through 29, that's 30. But if you try to go too high, it's going to like tell you, sorry, bro, can't do it. So let's go back to zone 2, and whatever, we'll just put in 10. You can see this is all updating right in front of your very eyes. So you can kind of see where this is going now. So since we've used basic mode, we don't need to play with these coefficients. These are all dealing with the foundational volumetric efficiency shape. The cam coefficients then overlay on top of that, and they add to it. So let's see if we can knock this out. So if we, and by the way, this operates the same as HP tuners, like where I can type 0.9 and hit multiply. But I find it easier to use these things to go quicker, right? So I can, you notice as I'm taking this out, they're actually getting worse. So I probably want to start adding to it, get them kind of close. And now let's see if this guy does anything. Yeah, kind of overshot it a little bit. I'd say that's not too bad. I mean, we are 1.73 and 2.64. That's pretty tight. I like this. So I want to save this. So I can hit save the coefficients. Now you're probably going to need to iterate and what happens if we're at 20 degrees. Hey, not too bad. So you're going to need to account for that. And you can play around with this. By the way, this value for current air mass, this is pulling in these coefficients live as you mess around with them. If we do original air mass, this is going to be pulling from all of these guys. Now, as you go through here and you hit save, and it saves back to raw coefficients, then original air mass is still going to pull from that. But you can, like I said, probably shouldn't be playing with these here, but we need to put this on current. And you can see as I do this, it's growing. I can move this around. This is why I say the cam stuff just is overlaid on top of the normal volumetric efficiency determined by these coefficients. Kind of showed you the zone focus. So this one might be the confusing one, and I may end up taking this out. I'm not really sure what I want to do here on this one, but this is basically showing you what happens to this zone, not if we stretch it out to infinity, but if we allow it to play out with these coefficients across the full RPM range and the full either the map sensor range or the map barrel ratio. And this can help you identify in terms of zone boundaries, like where they intersect. And I think if I go out here, under the help menu, if we go to, I think it's this one. Yeah. So this is kind of my thoughts on virtual volumetric efficiencies. There's like a few key points, and one of them here kind of talks about the intersections and zone boundaries. So you may want to take a look at that um, and go from there. Uh, and I know this may not make a lot of sense, but it is kind of important to see because, like I said, uh, the, the boundaries, the zones, I should say, the shapes of the zones are determined by math. The virtual volumetric efficiency table is absolutely not interpolated like any other table. It doesn't average between the two cells. Instead, it takes these raw coefficients and it applies them in a mathematical formula using the RPM, the map sensor or the map barrel ratio, and then the cam angle and puts them all together to determine what value is the final air mass. And so when we look at our histogram, well, what happens, like you can see I've added 2999, and that's when you look at this, you see that little step. Where did it go? Oh, well, I had it on there in the previous. You may have seen it, but at either rate, kind of lost my train of thought there. The interpolation. So you just want to make sure that this is playing out over the whole area the way that you want it to. Um, yeah, I know I was talking about the breakpoints. So what happens when you are at 31 or 30 or 3300 RPMs? It doesn't interpolate it. It plugs 3300 into the equation to find out what it is. What happens when you're at 37? What does it do? Our breakpoint is at 36 and 38. Well, what does it do? And that's where you get to these real funky intersections of zones. So how does this zone look to the computer when you're in this funky transitional state? And that's kind of why I added this 2999. And if you look in here, I think I kind of mentioned something about subtracting one in there. Yeah. So in this example, 2800 goes to 29. And if you look, you can see there's this weird jagged stair step. And that's because when this zone plays out over infinity, you may think that you've hit your zone breakpoint, but the computer says, I haven't reached it. I'm still going down. Now, the Gen 5 computer looks like it's starting to fight that whole idea, and you have this zone RPM hysteresis, and then you also have the map barrow hysteresis right here as well. So it does have a little bit of built-in protection um, for that, but you still need to take into account. And I realize I probably am not describing this as best as I possibly could. Um, I may take this out. I don't know. We'll see. But it's there for now. And, I don't know if you ever wanted to look at your histogram in a 3D form, but, you certainly can if you want to. But this is like your 1-2 punch, your 1-2 combo. Is going to be looking at this histogram here, messing with these variables, and you could change them manually if you wanted to, um, and knock them out like that. But either way, when you're done, you just hit save the coefficients. At that point, you would come in here, and anything that you've changed should have a color to it. So at this point, if you just hit copy to clipboard, and now you'd come back over here, and we were at this guy here. I could just say paste, and there's our value, that 19 that I put in here. So this is how you would get it out of the tool. Again, I am looking at a workaround to automate getting things in and out without having to do this whole copy and paste back and forth. It is a pain in the butt, I know. And then, when you start thinking about if I can get the calculate the coefficients functionality in there and have the tool iterate itself, generating the coefficients and manipulating them to try to find the best outcome for the fuel trims, I mean, it's self-tuning. Like, it doesn't get any better than that. Anyway, I hope you got something out of this. I hope you learned something. And if you're still having questions or having trouble wrapping your mind around this, feel free to reach out to me on the forums. Again, my username is Cringer. Just shoot me a message. Be happy to chat with you. Appreciate your time. Thanks for watching, and happy tuning. Later.